Hello, I'm Rosstin. I'm a researcher at IBM. For the last year, I've been working on an augmented reality data visualization app called Immersive Insights. So, in a nutshell, this is something I've been developing as a tool for data scientists and researchers. One of the things that I see when people develop immersive data visualization tools is they don't seem to know who their audience is. I see roughly two distinct audiences for these tools. You have your researchers, people who are studying genetics, people who are doing climate change models with geospatial. These people need 3D. They're already using it. They have n-dimensional data sets that they're trying to push down into 4, 3, or 2 dimensions if they have to, and the more dimensions they get, the better. And there are also kind of these CEOs and marketing analysts who kind of want something that's more fun, more of a toy. I think that to drive adoption of this kind of technology, what you've got to build is not a toy, but something that's truly useful for a researcher, which is why I've been seriously targeting scientists. Our tool that we've been developing is going to work alongside, already does work alongside RStudio, Excel, whatever tool you use professionally. This is there for you to be used with your tool. If you guys have all used Excel, I imagine that Excel has two components. It has a spreadsheet where you use your keyboard and you put in data and you do some manipulations. And then it has this graphing tool. So in Excel, if you want to use the graphing tool, you select your columns and your rows, and you hit graph, and then you've got this graph that pops up. And you can change that graph into a bar graph, a scatter plot, whatever. You can change the colors of the data points. So what I'm building on this headset here, this is the graph. That's what's on the headset. So your spreadsheet, we don't make a spreadsheet in virtual or augmented reality. Your spreadsheet is your spreadsheet. You get to keep that. So this has been kind of a long walk for me the last year. I started this in January. I had just finished my latest project, which had been some executive dashboard for Twitter data on the iPad. And in fact, my boss got promoted and left. So I was just there with no boss for several weeks, just kind of like not knowing what to do. And I saw Teresa Duringer's work on Bizarre, and I saw some of Colin Northway's stuff with Fantastic Contraption. And I was like, this VR stuff is interesting. I should try this. And my bosses thought I was crazy. They thought I was crazy. So I paid for all the original hardware out of my own pocket. I shelled out like thousands and thousands of dollars for a computer that could run the Oculus. And I illegally purchased a headset from a developer who shall go unnamed. Thank you, unnamed developer. And I got started with this. And when I got started, I was looking at Bizarre. And Bizarre has this sort of gaze-based control scheme, which was the best thing I've had at the time because there was no controller with the DK2 in January. And I was like, I'm not going to control this with my keyboard. I'm blind in this thing. So I started playing with the gaze controllers. And I very quickly decided that this was not what I wanted to be doing. One of the biggest flaws I see with gaze controllers for like a business environment, even just from a UX perspective, gaze controls are slow. I can fiddle with these constants however much I want, but I'm pretty much never going to be able to make this responsive. When the user wants to select something, I want them to select that thing in 1/10 of a second or less. I want them to instantly reach out and grab the thing they want. So this was not what I wanted to be doing. So I found the leap motion. And when I first started using the leap motion, it was terrible. I'm sorry, leap motion, but in January, you were terrible. And my bosses were like looking at this, and they were like, this is a waste of time. This is nonsense. You know, this is the Wii from whenever the Wii came out. But the Orion update in February changed everything. This is the day we got the Orion working. And suddenly, all they did was I think they changed like the occlusion algorithms for how fingers and hands occlude each other and how it like estimates where your hands are. But this update made it like really work. It wasn't just a toy anymore. It really actually worked. And this is when I started to get really impressed by controls. So some GIF here where I show control. Where are you, GIF? Here's the GIF. And like it's just very precise. And when I used those hand controls, I was like, this is better than the mouse. You know, I've been working in Unity for a long time, and I think we've all had the experience of using Unity and dragging things around with those little sliders, and you're like, where is this? Like, should I use the orthogonal perspective controls? And you can't figure out where stuff is. But this just changed everything for me, being able to really control things in 3D. And I learned a lot from working with the leap motion. Some of the little tidbits I picked up. So one of the biggest things I learned was, the first thing we saw was all the VR at the time was restricted by the length of your arm. So I was trying to make this thing where you can manipulate these graph data points like a social network. And I was looking at this thing that was supposed to be on my desk, some data point, and trying to grab it, you know, and like my arm was not long enough to reach it. And I was like, why am I doing this to myself? Why am I forcing myself to be restricted? My buddy Albert works on this game called Museum of Simulation Technology, where you can look at the moon and grab the moon out of the sky, and it's the size of a marble. And I'm like, it should be like that, right? I should just be able to reach out and grab anything I want and pick it up. So that's one of the first lessons we learned about not restricting yourself to the possible, right? This is virtual reality. It's supposed to be transportational. If I make a virtual environment and I put you at a desk in a space office, what am I doing, right? You already have an office. So it's really about taking you somewhere else. Actually, when I was still working with the virtual environment, what I had instead of a virtual office was we made like a magical VR spaceship where you were just like flying around in outer space and you were manipulating graph data from Twitter. And it was cool. It was just boring enough that I didn't scare the executives. Because like space is like on that intersectional point where it's like space is cool, everybody agrees space is cool, but it's not like anime or something, right? It's like, okay, space, we can handle that. That was a big challenge, you know, for me, is the executives were very afraid of VR because it didn't look professional, right? It looks kind of silly. And I had an uphill battle to make it look professional and to make it look like a serious tool. So really, the point at which things changed for me is when I presented my work at Spark Summit, right? Because Spark Summit is kind of a big deal. This is like the successor to Hadoop, right? So then they started paying attention to me and maybe considering giving me money, because everything came out of my own pocket. Just $5,000. So after Spark Summit, we'd had some success with this graph data visualization, and I needed to show something new to keep people interested. It's really dog eat dog world. If you don't get something new out there every second, you're not going to be impressing anyone. So I saw this mixed reality stuff that Colin and his team had been working on with fantastic contraption, and I was like, I got to try that. So I got an HTC Vive, and I went to the hardware store, and I almost got fired for drilling holes into my office walls. But I didn't. My boss, Sherry, saved me from being fired. And I think the big deal with MR was that it solved the problem of conveying what VR feels like. Because when I was showing people VR, they didn't really get it unless I put them in the headset. And some of these guys really didn't want to go in the headset. They were kind of, it was too silly for them, right? Because they're wearing these expensive business suits and, getting paid hundreds and hundreds of thousands of dollars. You're not recording this, are you? It was like, this was too silly for them. But this let us show them what it felt like to be in virtual reality without actually putting them in virtual reality quite yet. Comparing the HTC Vive to the Oculus, what I would say about the HTC Vive is that HTC Vive is a much nicer and more complete professional experience than the Oculus Rift. Don't tell my buddies at Oculus that I said that. But once you do all the work and you get it set up, which is a lot of work, the HTC Vive is very complete. Comparing the wands to the hand controls, I think that in a business context, hand controls are going to be the real thing because they don't require you to have a bulky controller. However, if I was going to have a room in our building where I took clients to demonstrate this technology, that room would have an HTC Vive in it. Because once you've drilled into the walls and you've got all the hardware set up, the Vive is very self-contained. It does everything you want it to do. The hand controllers work perfectly. There's never an issue with pressing a button on a controller. So for right now, the hand controllers are very solid. I really like them. So the Vive, we didn't really spend a lot of time with the Vive because I had a lot of trouble making our application work in VR. VR is very challenging for a business application. So one thing I was always struggling with was I want the user to have a keyboard. I don't really feel like I can replace the keyboard in VR. So this is one of the wacky experiments we did with Leap Motion where I had it so that when you pressed your finger on a key, the Leap Motion would know where your finger was in space, and the keyboard would know which key you pressed. And I knew what the shape of the keyboard was. So I would try to draw the keyboard in 3D space, right, based on the key presses. But it didn't work very well, because the Leap Motion's knowledge of where the ends of your fingers are is not perfect. It's good enough for what we do with the gestures, but it's not good enough to show me where your keyboard is perfectly. Like, if I had finished this, I think the keyboard would have been kind of constantly jiggling around and not really quite always know where it was. Probably would have made you a little bit queasy. So that didn't work. And the other things we were struggling with was, how do I give the user a window into their desktop? Now, one of the major advantages of VR that I don't have in augmented reality is that I can have infinite spatial real estate. I have an image somewhere of this stock trader, and this stock trader has 13 TV screens just around him, like physical TV screens that probably cost like $100,000. And in VR, you have that for free. Your headset is one giant TV screen that covers your entire 360 degree. But even with that advantage, it wasn't enough to justify taking away the user's computer screen, I felt. So when our bosses forced us to switch to the HoloLens, the director of design was interested, and he told me, you have to switch to augmented reality. And I was like, well, who's going to make me? You and what army, right? And I didn't say that because I really don't want to get fired. So what I did tell him was, look, if you give me 4 HoloLenses, I will port my work over to the HoloLens in a week. And he did that, and then we did that. So as reluctant as I was to start with the HoloLens, once I actually started working with it, I was really impressed. Now, so this is just a little thing about our application here. So as I mentioned before, I don't want to replace your tools. This is, DSX is one of our offerings at IBM. And within DSX, you have access to our studio. So basically what our application is the client, it's like 100,000 something lines of code, runs in the HoloLens. And then there's this little plugin that runs in our studio. You just load it up. And the plugin is like 100 lines of code. It just says, this is where our server is located. Please send your data like this. And when you're using our studio, you just type VR plot. And then it goes to our server. And then the server's like, hey, HoloLens, we got some new data. And it goes in. I'll show you that later. But as you can see, this guy, he's selecting the data. And then he hits enter. And then bada bing, bada boom, in how many seconds? In 2 seconds or so, it comes and it pops up in the HoloLens. So it goes up to our server and comes down to the HoloLens. But anyway, once I started doing this, I started realizing, okay, I should have been doing this a long time ago because this solves so many of my problems. So I do want to say the HoloLens was not what we expected. The videos that Microsoft shows are a bit aspirational. It's very heavy. It has a tiny field of view. It hurts my face because it pushes up against my glasses. And I don't know, it's like some kind of Sword Art Online headset. And it costs $3,000. And Leap Motion Orion still has better motion controls than the HoloLens. But, okay, with all of that, with all of those issues with the HoloLens, it instantly solved all of our computer interaction problems. Now you can use your keyboard, you can look at your computer screen, you're not bound into this virtual world anymore. As I started using it, I started to realize, VR is transportational, right? It takes you and it sends you to the moon or outer space or an alien planet. But augmented reality is transformational. It will transform the world you're already in. And for a business context, that's exactly what you want. You want to be able to be social. You want to be able to see your desk phone. You want to use your computer keyboard. So we were able to very successfully separate these various domains that we were living in. We have this domain of data science, which is spreadsheets, MapReduce, and all these kinds of things. And then we have this other domain, which is the 3D visualizations. And for the 3D visualizations, that's where we use the interaction models that are for the 3D visualizations, right? We use hand gestures and voice commands. So in a nutshell, this is sort of my conclusions for now for augmented reality, for immersive data visualization, how controls map, right? Your computer mouse would be hand gestures. And as those improve, those will get better and better, especially for manipulating 3D objects, because we've never been good at doing that with the mouse. That's always been crap with the mouse. And the keyboard shortcuts, I found this very quickly that when I wanted to do debug stuff with the HoloLens, I just started using voice commands, which are pretty good. I have one that's like debug log activate, and it just brings up this magic debug log that just tells me, and it kind of stays just outside my field of vision like a creepy stalker. But it's very useful because I'll just look and I'll be reading the debug log. So keyboard shortcuts are basically how I imagine voice controls are in augmented reality. And most pleasantly, your keyboard is still your keyboard. You just get to have your keyboard and use your keyboard. Nothing's better than the keyboard yet. Keep it. So that's kind of the short version of what I've learned. I have a lot of more material that I can go in more depth. So if anybody has any questions, I can talk about a lot of stuff. So go for it.
So you were talking about how intuitive it is to move objects around in VR and AR, and that's because you're seeing a stereo.
Yes.
Walk around
Yeah, I got a whole thing about
that.
that.
You also talked about being able to do stuff at a distance, and it seems like those are fighting with each other, because the thing that makes it intuitive to move stuff around in your immediate vicinity is also the thing that makes it impossible to reach out and grab the moon at scale. So did you explore that kind of paradox at all and figure out a way, a good sort of user experience way to mitigate that?
A little bit. So one of the things I struggled with moving from VR to AR was in VR, I was imagining my metaphor for the social graph data points as like a galaxy or a constellation. So I was like, you're here, you're in your magical data science spaceship, and you're at the deck, and you're like, oh, I'm moving the stars around, And then when I moved to AR, that didn't work anymore, because you're in your office, right? So, I had these scale issues where you were trying to manipulate the data points. It felt weird, and I realized I made this mistake that, in fact, if you use the Microsoft HoloLens version of Unity, the sample scenes that come with it, the scale of all of the objects, so Unity has that measurement yardstick where 1 meter is like 1 unit, roughly, right? And in the HoloLens, all the stuff they give you is like centimeters and millimeters big. So, you have all these tiny objects. And that was what I had to kind of switch to. So I stopped seeing things as constellations and galaxies, and I started seeing them as, this little universe that I was kind of working with.
Thanks for your presentation. I have 3 questions. The first one is, did the field of view bother you in the HoloLens?
Oh, yeah.
The second and third one was, did you measure the amount of time a data scientist or any of your end users would be in AR versus VR? Because I found, for me, VR is it's too short to have someone for more than 10 minutes if you're actually, in the B2B workspace, working. If I'm going to have, it doesn't work. So I've been more in the AR space. So I was wondering, how much time, what's the max length of time you would have someone actually in AR, in a HoloLens in your work. The third question was about data processing and what you did to pre-process everything on Apache Spark and then actually visualize something, because the other demos that I've seen from developers are pre-processed data.
Exactly.
Or creating a CSV, and I'm like, that's not really big data. Or we're taking something from a JSON file, and I'm working at petabytes of scale. So to take a sampling from that is very different. So I just wanted to know more about your development process too.
Absolutely. So I guess I'll do those in reverse order. So pretty much, I don't believe in canned data. If your data is canned, what are you even doing, right? Because like I said, this is not supposed to be a marketing toy. This is supposed to be a real app. So if I have time during Q&A, I can show you the real app. I have a buddy who's in the office, and when I say the word, he can just press a button on his keyboard and the data comes down. So basically, that's why we have a server. The server can have as much data as it wants because we have this massive server. And the challenge with the data points, so when I look at big data visualization applications, one thing I've noticed and one thing I've struggled with is most data visualization applications don't give you living data. I'm not saying they don't use living data, but you'll use living data and then they'll print out like a dead, like printed tree version of a visualization. And so like Gaphy, I think, is the one. It's very good, very useful, but you can't hover over data points in Gaphy. Once you've plotted them, it's just a PNG file. So at scale, it's been very difficult to do this. That's one of the optimizations I've been working on the hardest, is having billions and billions and billions of data points all interactable. And I'm using some Octree stuff to kind of work on that, basically solving the first-person shooter problem of how do I shoot a trillion guys and not have that take more than a frame. So our application is real. It's not canned at all. So that's don't can your data. Don't do that. And what was the second one?
The length of time someone is in AR, like what's the max amount versus VR in your judgment, like if your customers are data scientists or data analysts?
So I think the HoloLens right now, has some serious problems. It's very heavy. It's not great for comfort. I can wear the HoloLens for about 3 or 4 hours a day, and then my neck starts to hurt. It's pretty heavy. And I do wear contacts when I use it because I don't like the way it interacts with my glasses. As opposed, well, the thing with the VR is you can't wear it that long because you're blind, right? You're functionally blind. I actually, before I started working on the augmented reality, I used infrared pass-through from the leap motion. I had a toggle on my keyboard that I would press to see it infrared, and I could sort of see like these blurry shapes, but not my like computer screen. So I really think augmented reality is going to be worlds better. And I also think that 2 years from now, I have faith that Microsoft has a lot of money and a lot of power, and I think that someday this is going to be the HoloLens, right? I wouldn't be developing for it if I thought this was the final product. But I do think that once it's real, once it's a consumer product, it's going to be like wearing a pair of glasses and you can wear it all day. That's what I believe.
Thank you.
I can get this guy. How are we doing for time here? Are we up? Anybody else got any questions?
Yeah, I guess my question is, can you give some examples of data where you think that actually viewing it in VR or AR or in 3D actually helped the process and it was just not just a gimmick?
Bam, there you go. So this is a 2D graph data set versus the 3D version. This is MNIST data, which is about characterizing handwriting. So these different colored sectors represent what the computer thinks are different letters. Okay? Now, when you're working with graph data, what you want is you want to avoid crossing, and you want your regions to be distinct. So as you can see here in this 2D example of the data set, everything's kind of muddled together, and some of these groups are sort of mixed up, and that's not what you want. So in 3D, mathematically, it's always possible to avoid line crossing. You can just always draw a line between 2 points that doesn't intersect another line. And this is just better. I have a million more examples. Another thing I like to think about is how we've been optimizing for decades on 2D. right? Optimizing visualizations for 2D. Even when you look at a really nice 3D visualization in 2D, what you're looking at is something someone slaved over and curated to make it look nice, right? And the great thing about visualizing in 3D is you don't have to make it look nice. You can just plot it, and it being natively in 3D makes it easy to actually get what you're looking at because you got the depth perception, right? This is an image I love from an O'Reilly book, which is just, what is that? Right? But in 3D, you could see that. It would still be a terrible visualization, but you would be able to understand where those data points were, right? And so I've been working with this for about a year, and I truly believe that 3D data visualization will be so useful, you won't even imagine how you lived without it once you've had it for a decade. Yeah, I could go on with that. I got a million stuff about that. Yeah.
Were there data scientists or executives who were skeptical at first who changed their mind after they tried it?
Yes.
Do you have any stories or anything?
No, they just tried it and then they were like, okay, I believe you.
This morning, in this very same room, actually, we listened about the web VR and how the future of VR is very linked to the web experience. I hadn't had the time to make the question about a potential AR web. So the question is, how long, in your view, with your experience, are you looking into the consumers and the world to be able to data visualize a web experience? I'm not talking about the Hololens timing. I'm talking about how that kind of technology and infrastructure is going to be ready, at least, to interact with big data in order to
on the web. I don't really understand.
On the web, yeah, the web instead of a web VR, the web AR or something like that.
It depends on what you mean. For instance, if you mean you're a data scientist using a notebook, right? Is that what they're called? Notebooks, not workbooks, right? I always get those two mixed up. Yeah, exactly. So we have a million Jupyter notebooks at IBM on like Apache Spark and stuff, right? If you want to do Jupyter Notebook in AR, I got you covered, right? I can write a plugin for that in like a couple days, right? So I think that would be real right away. If you're talking about like us living in the virtual web constantly, I don't think that's going to be a thing for a while until our kids like get jive with that.
Thank you.
Yeah.
What's the main type of data sets that you're working with? Because I did see it looked like elections data.
Oh yeah, yeah.
Stuff in the biotech space, so I was curious to know like what other use cases and data visualizations you had other than plotting like a lot of different data points that look like little. To me, it's like.
Yeah. So I mean, as you can see, as we got started, I didn't even know how to like visualize this stuff. So just a bunch of balls with these shitty like 3D text that has that like blurry texture that Unity has. Geospatial was like one of the best use cases once we actually got started. So there's this cool moment I had when I was doing some geospatial stuff, and my buddy Jay was working on the data set, and I was just messing with the app and trying to improve it, and I was just seeing the data just like popping into my face as he was doing it, which was like the collaboration potential started blowing my mind. But like geospatial has been great because we'd plot like these bars, and you could just see, oh, that bar's taller, and that's in New York and stuff. The geospatial is really good because it's innately 3D, so you want it in 3D. I think I've been talking to some researchers at Berkeley who already do 3D visualization. They work with like genetics and chemical interactions, and they're already doing 3-dimensional plots. So I think there's a lot of scientists who are just already doing this that need it. The social graphs is obvious. I don't know how useful those are. They're a lot of fun. But I think that there's just going to be more and more use cases, especially as this becomes easy to use. Like, I think about the visualizations we have now. Oh my, too many slides. We have, we got kind of scatter plot. We've got geospatial, and we've got graph, like social graph. And I think what's really going to be good is when we don't just have those, but we have visualizations that were developed from the ground up for augmented and virtual reality. So that's what I'm really looking forward to. I don't have time to work on that, but yeah. Okay, that's it, guys. Thank you.